Welcome back to the Professor's Du Bois channel. I am Professor Victoria and this is Professor Corey, and today we are going to be talking about percent yield.
All right, so percent yield is something that we're going to have to calculate based on our actual yield. In our previous video, limiting reactants, we talked about how we can determine a theoretical yield. Right? So we have, let's say we have two reactants. We have to determine using stoichiometry how much product each would make. And the one that produces the least amount is the limiting reactant. And the amount that is produced by the limiting reactant is this theoretical yield. But when you do these in the laboratory and you measure your product, that's your actual yield, what you actually got. And it's usually less than the theoretical yield. Now, the percent yield is just a calculation comparing the two amounts.
I think that's a really good point, that's usually less than theoretical yield because we have losses. Theoretical, I can't talk and write at the same time. So theoretical yield is the maximum amount that you could possibly make. The actual yield is what you did make and what you recovered once you had all of your losses and you did all of your operations in the laboratory. And the percent is how much as a percent of the maximum that you could make did you actually recover. And of course, if you're trying to do some type of production facility, you want to maximize that percent yield. You want to make as much product as you can. So how do you calculate percent yield? So this is the formula. So your actual yield is what would be provided for you in the problem. And your theoretical yield, you usually have to calculate that. So your actual yield divided by your theoretical times 100. So for example, if you calculated, this is usually a calculation, and determined that you could, this is the maximum amount that you could make, was 562.5. And the problem told you that you had 501 grams recovered, produced, measured. Those are all words that you might see in a problem. Then you would set up your division, multiply by 100, and get your percent yield. And it does follow the significant figures rule. So we have 3 sig figs in our measurements up here in our problem. So our percent needs to be the 3 significant figures as well.
All right, so here's an example. We've got a reaction. This is propane. We have an amount. And notice how it says it's allowed to react with excess oxygen. That word excess oxygen is telling me that the propane is the limiting reactant. And that's kind of nice. We don't have to do 2 equations here. Another clue is we were only given the mass of one of the reactants. So when you have a limiting reactant problem, you get masses or moles of both reactants or all of the reactants if there's more than 2. So we know what the limiting reactant is. That's the propane. So we can start there. Now, as always, we need to balance the equation first. So they gave us the equation. Always check to make sure it's balanced. I don't see any coefficients here, so I'm suspicious that this one is not balanced, and it is not. So the first step, balance your equation. So they want to know what is the theoretical yield that can be formed. So that's going to be based on the 9.65 grams of propane. We're going to use that mass. We'll go to moles, and then we'll go moles of propane to moles of CO2, and then to grams. That'll be the theoretical yield. Now, notice at the bottom, if 14.6 grams were collected, that's the actual. So we ran the experiment, and we measured, we had 14.6 is what we actually got. This is probably going to be less than the theoretical yield, but we're going to use this along with the theoretical yield to get the percent yield.
Okay, so here's our calculation. We have a balanced equation up here now, and we do have a video that talks you through balancing equations. If you haven't seen that, go back to that. So we have a balanced equation up here. We start with what we know that's not a factor, and that is our 9.65 grams of propane. So I'm going to start with that on the left and continue to cancel units. And so I'm going to put my grams of propane in the denominator. This is from the periodic table. Our molar mass of propane. So once we've converted this to moles, we are on what we call mole island, and we can use the next step to convert from one thing to another. And that's the only time that you can convert from one species to another is in moles. So the moles of propane we're going to cancel. We have 1 mole of propane for every 3 moles of carbon dioxide, and that is from your balanced equation. So that's our coefficients up here. When you don't have a coefficient, that's implied 1. So 1 mole of propane produces 3 moles of carbon dioxide. We want to know what the theoretical yield of carbon dioxide, our product, is in grams. So we have one more step. And again, this is from the periodic table for CO2 this time instead of propane. And we convert that to grams. And we have 3 significant figures. So this is our theoretical yield. That's the maximum amount. If all of the propane reacts, how much CO2 can we make? There's our theoretical yield. That's part of what we need for our percent yield.
So again, they told us how much was collected, and if you were working in a lab, you would be measuring this amount, your actual yield. So we have our actual yield at 14.6 grams, what you actually got, over the theoretical yield. That's what we calculated, the 28.9. times 100, and we ended up with a 50.5% yield. So this isn't real good, you know.
Not if I was selling carbon dioxide.
Yeah, if you were trying to produce this, you want to really maximize your product. So this is where, you know, you can make a profession out of improving yields. And, you know, so where would you start? Well, you know, I look at this, it's all gases. Maybe we got a leak. You know, let's make sure we're not losing some of our product for a leak since it's gases. I don't know. Maybe we're not getting a complete reaction.
Might not be burning fully.
Yeah, you have to, you know, study each of the steps and to improve that yield. And you would certainly be able to improve that yield over time.
So here's a practice problem for you. And it is the same reaction. And this time we have, it is a limiting reactant problem. So you have to convert your grams of propane into grams of carbon dioxide, and then also convert grams of oxygen into carbon dioxide and see which one is smaller. The smallest one is your theoretical yield, and whatever reactant led to that is your limiting reactant. And you have some amount of excess that is remaining of the one that was not limiting. And then at the end, you can do your percent yield.
So go back and watch the video on limiting reactants if you're unsure on how to calculate that excess reagent.
Good practice.
Or excess reactant.
Pause the video and give that a try.
All right, here are your answers. I forgot to mention in the question that equation was not balanced. So hopefully you balanced the equation first, and hopefully you were able to get these results.
So that's our video on percent yield. Thanks for watching the Professor's Du Bois.
Bye.